the project on from equations how we are going to how ML algorithms are getting intelligent. Means now the AI is booming and it is properly impacting all the sectors. But everyone says that there is a mathematics behind it. But I will try to show how the equations are giving the intelligence to the ML model, and we will use the intelligence to predict the heart disease. These are the content that we are going to see. The project will help us to understand the complete cycle of a machine learning project. First, we do exploratory data analysis, means we have to first find the data. I took the hard disease data set, then we will do cleaning, and then we will apply statistical techniques to understand any insights from the data. Then we will use to evaluate a model, we need a matrix. The matrix, we use classification matrix, accuracy, I will show them, and we use the logistic regression supervised ML model to understand how the equations behind it are giving ingredients to predict the heart disease. And the aim of the project is to show how the equations are giving ingredients and we use the ingredients to the heart disease data set. And first exploratory data analysis is nothing but getting the insights from the data and also finding what are whether there are any missing values, whether there are any outliers, whether we can able to create some new columns out of the data. We are able to understand those from exploratory data analysis. This is a first and foremost step that we do after data analysis. And I took a Birmingham data set from Kaggle, and it has 4240 records, and these are the columns. Features like male, whether it is male or not, what is the age, education, whether they smoke or not, or how many cigarettes they smoke, and what is the blood pressure, systolic blood pressure, BMI, heart rate, glucose, and these are the features that are present in the data set. And what is the target label? We have to predict 10-year CVD, means whether they will be having the cardiovascular disease after 10 years or not. Means some new data is given with these features. I have given I know I am a male, or whether what is my education, whether I smoke or not. If I get all the details after training a model, then our model should be able to predict whether you are able to get the cardiovascular disease after 10 years or not. And we'll see, this is how the data, first 25 rows of the data set will look like. You can see that all of them are numerical. We don't have to convert them into any other form. Means we need a numerical data. Since it is numerical, we don't do any transformation on the data. And first we have to check whether there are any missing values present in the data or not. That is very important. And I say, and you can see a missing value percentage for each column I have written. You can see the code output. At the end, I will show the output, the actual code that I have used, and you can see 4040, and you can see the null values. Means after running the code, the right side one is the output. Means all of them are completely filled. 4044 to 40, all of them are null. How I have imputed? Means let's say a numerical column is there. A numerical column I have imputed with the median, and for a categorical column I have imputed with the mode. Means let's say numerical column has a data, numerical column has missing values, then I imputed with median. For categorical column I imputed with the mode. Like that, I have filled the missing values, and then we have to understand the outliers present in the data. Whether they are outlier, then the box plot will help us to find the outlier. If the data for a particular feature is more than Q3 plus 1.5 into interquartile range, and that is the median. Difference between Q3 and Q1 is the interquartile range, and if it is more than Q3 plus 1.5 into IQR, then it is the outlier, and minimum this is also outlier. And this is a box plot. From this box plot, we can clearly see what are the features we are having the outliers, and these are the insights from that. There are significant outliers in these features like systolic blood pressure, BMI, heart rate, and total cholesterol. For any person who are have to treat on the cardiovascular, hypertension, and their age, and those are the important factors that the box plot is telling. And then histograms. In histograms, you will be able to understand how the dominance of the two classes. Right? These are the insights. Majority of the population is from 40 to 70 years old, and the features these have only maximum columns and maximum values are 0. Like prevalent stroke means the data set is as a top quality data set. Means we have so many unbalanced. It is an unbalanced data set in terms of features, in terms of the target variable as well. I will show that. And this is a correlation matrix. You can see that, right? Correlation will be more correlation means orange color will be there, red color will be there. So you will see the bar on the right side, and these are the inside top correlated features are those, and you can have a scatter plot to understand from the top correlated features how it is correlating with the target variables. And these are the metrics that we use. For accuracy, precision tells how much, what is the ability of the model to not classify as a negative as a positive, and recall is a positive and negative as a positive. You can see here, first score is the harmonic mean of those two. And logistic regression, the main aim of the project is to see logistic regression first assumes equation. Initial y equal mx plus e equation. You can see 0 into first column, 0 means all the weights of the column features are 0 initially, and we use gradient descent to update the values of the weights, and we can see a 30th regression. This is the equation of the model. You can see 0.139 into male, 0.35 into a, means we can see we are updating the equation of the model. We are making it better and better by iteration, and you can see how the training loss is training loss is slowly going down and accuracy is improving. And these are the weights, how weights are changing, and that is the final equation, 99th equation. And this is the feature importance. These are feature importance. Feature importance is that what are the features that the model thought which is very important to predict the target label. See, machine learning has the interpretability, but deep learning don't have. This is why most of the clinical techniques in real world they apply machine learning rather than deep learning, because they will understand why the result is like this. And this is the evaluation matrix, confusion matrix. From that you will get F1 score recall. And the conclusion is this. We use a simple linear regression. Means simple model y equal to mx plus c. Using that, we are able to find a model which were able to find the hard disk. Means the mathematics is simple, but the mathematics application is very important in the real world right now.